So I have a question here from a Cal 1 student. I've been getting a lot of emails, but very, very few of them about math. They've all been about my grade. How is this going to be graded? How is that going to be graded? What's this going to do to me? And all this kind of stuff. You know, I can tell you in general that everybody at the university is keenly aware of how stressful and difficult this situation is. And nobody wants this to have a negative impact on anybody's success. Okay? So, you know, you signed up for a face-to-face class, and you ended up getting an online class in the middle of the semester, and everything's kind of, you know, has to be redone. So everybody's aware of that, okay? And nobody's trying to you know, take this opportunity to make you fail, all right? So keep that in mind. Relax about your grade. You're going to be fine. Learn the mathematics, and that's what's expected. So we have a question here, like I said, from a Cal 1 student. And the question is to find the critical numbers. Okay, so we're looking for the critical numbers of this function, okay? 6 secant x plus 3 tangent x. Okay, so we want the critical numbers. So when you hear critical numbers in Cal 1, critical numbers, immediately from your memory, you have to pull up first derivative, set it equal to 0. Okay? That's how we get the critical number. So you take the first derivative of the function, and we set it equal to 0. Now, taking the derivative, again, you know, there are 9 rules for taking derivatives, right? Okay, so let's get the derivative of this function. So f prime of x. 6 is a constant multiple, right? Constant multiples go along for the ride, so the 6 stays there, yes? Okay, the derivative of secant is secant tangent. That's the derivative of secant, okay? Again, from your memory, it's one of our 9 rules, right? And after we take this derivative, we look at this and it's just x, so we're done, okay, with the chain rule in this case. So derivatives don't change sums. The sum of the derivative of a sum is the sum of the derivatives. So plus 3, again, constant multiple, right? Goes along for the ride. Derivative of tangent is secant squared. And then x, and the derivative of x, which in this case would be 1. Okay, so there's our derivative, okay? And we need to set this thing equal to 0. Now, you know, this is a trigonometric function, obviously, okay? But we can use some algebra here, okay, to make setting this thing equal to 0 a little bit easier. We're going to factor it. You see there's a secant here, there's 2 secants there, right? And there's a secant here, so we can factor out a secant. We can also factor out a 3. So we're going to end up with 3 secant x times what? 2 tangent x plus 3 secant x times secant x is going to give us 3 secant squared x. So now we can say that since these two things are multiplied, anytime one of them is 0, the product is going to be 0, right? So there are a couple ways we can do this, but with these secants and tangents, okay, sometimes it's easier to visualize this thing if we go ahead and use the definition and write these things in the simplest way, sines and cosines, right? So we've got 3, okay, so secant's 1 over cosine. 2, tangent is sine over cosine. And secant again is 1 over cosine. Okay, so when this is 0, the product will be 0. When this is 0, the product will be 0. So 1 over cosine x. So when is 1 over cosine x equal to 0? Well, there's another thing that we know, okay? Again, this is something that we've memorized, okay? Is that for a fraction to be equal to 0, okay? It's the top that we're concerned about. The bottom of a fraction can't be 0. That's not a reasonable number. So in order for this to be 0, this means that a is going to have to be 0. In other words, it's the top of the fraction that we're concerned about, okay? So here we have 1, right? Well, 1 is never 0, okay? Now, cosine can be 0, but then this thing will fail to exist, and that's not what we're looking for here. We're looking for when this thing is 0, okay? So this thing is never 0, okay? So we kind of don't have to worry about that one anymore. Now we need to focus on this one right here, okay? So let me get some room. So what we're concerned with is when this thing here is equal to 0. Now notice that we've got the same kind of a thing. We've got a repeated factor in here, right? Let's factor that out of it. So here we have, we're in the same position. We have a product equal to 0. This is going to be 0 when this is 0, or this is 0. Now we just said that this is never 0, okay? This is never equal to 0, okay? So the only thing we're really concerned about now is this statement here, okay? So we can just get rid of this stuff. And this problem boils down to this, right? So something plus 1 is 0. Well, this obviously is going to have to be negative 1, right? Negative 1 plus 1 is 0, yes? Okay, so for this product to be negative 1, 2 times what is negative 1? Well, this is going to have to be negative 1/2, right? So we end up with sine x equals negative 1/2. So here we go to the unit circle. Sines are vertical distances, right? So negative 1/2 is going to be below the line. So we have here 1/2, that's negative 1/2. And we have here negative 1/2. And you know these positions, okay? This is 0, this is pi, that's 6 pi over 6, this is 7 pi over 6. And that's 12 pi over 6, so this must be 11 pi over 6. By the way, I didn't write the domain. The domain for x in this problem is that it's going to be less than 2 pi and greater than 0. Okay, so it's once around the circle. Okay, that's kind of a standard domain for these problems. So we know the unit circle because we have it memorized again, right? So these are the answers right here. So x is equal to 7 pi over 6, and x is equal to 11 pi over 6, okay? If you have any further questions about this, go ahead and send me an email. To the student who did send me an actual mathematical question, thank you. I appreciate it. I think it's a good problem. Let me know if you have any further questions.